Okay, this is the second set of notes we're going to do in chapter 10, number 3. We didn't do number 1. We started at 2, and we're going to practice with adding, subtracting, and multiplying radical expressions. So we're going to go ahead and start with how to add or subtract radical expressions. And radical expressions are really no different than adding and subtracting like terms with the same variable. If the radicans match, then we can combine their coefficients. Okay, so it's simple as that. So let's see. So if the radicans match, then you're just going to add or subtract whatever it tells you to do. Add. Don't know what my problem is. I know what my problem is. I need to sleep. Subtract the coefficients. But the radicans stay the same. Just like if I had 2x plus 3x, I don't get 5x squared, I get 5x. Okay. Then if the radicans don't match, don't say there's nothing I can do. No, no, no. You got to go a little deeper. So if the radicans don't match, try to simplify the radican. If any terms now have matching radicans, combine those terms. Okay, so this goes all the way back to distributing and combining like terms, stuff you actually talked about when you were in 6th grade, okay? All right, so let's practice some of those. Directions are going to say simplify. I'm going to give you 4 of these. So number 1, we've got 3 radical 2, and we want to add or subtract 5 radical 2, and then add 4 radical 2. So first thing we do is we check out our radicans. Radical 2, radical 2, radical 2. They all match. So guess what? Boom, boom. Radical 2 goes outside. And again, this is a brain step. All you do is take your coefficients and you do the math with them. So you have 3 take away 5 is -2 plus 4 is +2, and your ultimate answer is 2 radical 2. That's about the simplest case that you will see in these problems. Second one, 4 radical 3 plus 3 radical 7 minus 6 radical 3 plus 3 radical 7. Okay, so what we're looking for is our denominator, our radicans. So 3 doesn't match with 7, but here's another 3. But I have 7s and 7s. Okay, so I'm going to group these by like radicans. So we're going to have 1 with radical 3 at the end. And then we're going to add to it 1 with radical 7 at the end. So we just grab the coefficients for each one of them. So for the 3's, we have a 4 and a -6. For the radical 7's, we have a 3 and a 3. So again, brain step, right? And let's see, 4 take away 6, we get -2 radical 3, plus 3 plus 3 is 6 radical 7. And that's it. All right, let's do another one. We have 4 radical 54 plus 2 radical 24. So 54 and 24 don't match. So we don't stop. What we do is we try to simplify, or factor our radicans and see if we can come up with a perfect square. Well, let's see. What do I know goes into both of these? I'll have a 9 times a 6 would give me 54. Oh, look at that. See, what I do is I look at this guy who's not the perfect square and see if he can go into my other radican, and it can go in 4 times. All right, so here's what we've got. 4 times, then we're going to take the square roots of these guys. Boom, boom, boom. And we're going to get 3 radical 6. And then we get plus. And then we're going to have 2 times. And then we're going to take the square root of each of these. And we're going to get 2 radical 6. So we multiply, and we get 12 radical 6 plus 4 radical 6. Because my radicans match, I'm going to do math with the coefficients. So again, another brain step. And I end up with the final answer of 16 radical 6. Now let me just kind of point out what I should see. I should see you kind of doing this. I should see what happens when you take the square root and you multiply it. Now, some of you may need to do this because this is a lot to keep in your head. And then you should get to here. All right, let's do one more like that. Let's have 3 radical 45, and then plus radical 20, and then minus radical 245. Holy smokes, that's crazy. Okay, so let me think about how to factor the first guy. So let's see, 45 is 9 times 5. So now that starts getting my brain to think about, can I come up with a 5 that's a factor? Yeah, 5 can go into 20 perfect square 4 times. All right, how about this guy? 5 goes into 24 4 times, which is 20 with 4 left over, and 5 goes into 45 9 times. Oh, ladies and gentlemen, do you see that? That's scrumptious. Absolutely scrumptious. Okay, so we get 3, and we're going to take square root of 9 and 5, so we're going to get 3 times 3 radical 5, and then it says plus, and we're going to take square root of each of those, and we're going to get 2 radical 5, and then it says minus, and we're going to take the square root of each of those, and we're going to get 7 radical 5, and then you should see same radicans. So we're going to just pull out the coefficients. So 3 times 3 is 9, plus 2 minus 7 radical 5. And 9 plus 2 is 11. 11 take away 7 is 4. So my final answer works out to be 4 radical 5. So again, what should I be seeing from you? I should be seeing this. And I'll either see, like, 6 radical 5 plus 2 radical 5 minus 7 radical 5, so probably this stage, and then we can get to here. Okay? All right, you should still be on one page. I need to shift my screen, and let's switch gears, and let's talk about multiplying radical expressions. Okay, so this one is going to be more like just not a monomial times a monomial. This could be a monomial times a binomial, or a monomial times a trinomial, or a binomial times a binomial, or a binomial times a trinomial, something along those lines, okay? Now, I didn't think about that until just now. Interestingly enough, you could use all of our strategies. You could do column multiplication, you could do the area model, or the matrix as I like to call it. You could do vertical, well, that's column. You could do just distributive. So all those things that we talked about in the first half of chapter 8, we could use with this as well. So not using, use the distributive property to multiply the radicals. So I'm going to give you a couple of examples. I'll give you just 2 monomials, and then I'm going to give you 3 examples. 2 monomials, a monomial times a binomial, and then a binomial times a binomial, okay? And then, again, always be sure to simplify radicans. So that's the main thing that we're focusing in on, is simplifying radicans. So again, same set of directions, simplify, fancy way of saying, or short way I should say, of saying, do everything you can mathematically until there's nothing left to do. So we have 2 radical 6 times 7 radical 3. So again, we're going to multiply coefficient with coefficient. And then we're going to multiply radicand with radicand. And then we're going to try to simplify, looking for perfect square factors. So that's going to give me 14 times 3 radical 2, which is going to give me 42 radical 2. Okay? So again, what am I going to see? I'm going to see that guy. I should see what you're thinking here. You might be able to do the radical 3. I kind of like seeing it. This one, pretty much. Especially as this is new stuff. Let's do a monomial, 3 radical 2 times a binomial, 4 radical 3 plus 6 radical 2. So we're going to start by multiplying radical 3 times 3 radical 2 times 4 radical 3. So we're going to take our coefficients, 3 times 4, and then we're going to multiply our radicals, our radicans, 2 times 3. And then it says plus, so we're going to write a plus. And then we're going to multiply 3 radical 2 times 6 radical 2. So that's going to give me 3 times 6 times the radical, and that would have us 2 times 2. So this is the brain step, basically. So we get 12 radical 6 plus 18 radical 4. So I can't simplify radical 2, but I do, or radical 6, but I do know what radical 4 is. This is going to give me, the square root of 4 is 2. So that's actually 12 radical 6 plus 18 times 2, which is 12 radical 6 plus 36. Can't simplify because there's no radical on the 36. So again, I should see this guy. I would see this guy, and then the answer, of course. All right, last one. We're going to have a binomial times a binomial. So we have 5 radical 2 minus radical 3 times the quantity 5. No, radical 5, sorry. Plus 4 radical 3. Okay, so this one I'm going to multiply the 5 radical 2 times the radical 5. So this is actually what I'm doing. I'm going to multiply 5 times 1 is 5. Radical 2 times 5 is radical 10. Now I'm going to multiply 5 radical 2 times the 4 radical 3. So let's see, that's a positive. So 5 times 4 is 20. Radical 2 times radical 3 is radical 6. Okay, so I'm just doing like things being multiplied. And then we're going to go ahead and multiply by negative radical 3. Negative radical 3 times a negative, or positive radical 5 is going to give me a negative. There's no outside number other than 1. And then 3 times 5 is 15. So we're going to get minus the radical 15. And then we're going to multiply the negative 3 radical 3 times positive 4 radical 3. So that's going to give me a negative 4. And then we have radical 3 times itself, which is 9. And then we're going to try to simplify. I can't simplify radical 10 or radical 6 or radical 15. But I do know that the square root of 9 is 3. So I get 5 radical 10. Ugh. Make sure you write things clearly. There you go. Plus 20 radical 6 minus radical 15. I don't like my 5. And then we're going to have minus 4 times 3 is 12. There's nothing I can do mathematically because my radicans don't match, so that's my answer. And there you guys go. All right, have a good one. Bye.